theorem. This theorem is going to be the most we have to write in words, and then we will have a couple examples that do take up a little bit more space. So, in the triangle inequality theorem, in order to create a triangle, okay, so in any triangle that's created, or any triangle, just in general, two sides added together is greater than the third side. So in order for it to work, the two sides added together have to be greater than the third side. Okay. For this, I'm going to be using green, orange, and purple. So if you would like to do this with me, you can. You can grab green, orange, and purple, but you shouldn't be grabbing a bunch of reds and a yellow. Green, orange, and purple if you'd like to just follow along with this. So when I put two of them together, it has to be greater than that third side. So if I put purple and orange together, why does that have to be bigger than green? Yeah, in order to make a triangle, this has to come down into that angle. And in order to come down to that angle, it has to be shorter. It gets smaller. Okay, so we're going to use this one as an example. I'm going to draw this over here. So I'm going to have this triangle. I'm going to call this A, B, and C. And I'm going to color code it just so it looks exactly like this. So AB is going to be my green. BC is going to be my orange. And AC is going to be my purple. Alright, so when we take any two of the legs, it should be bigger than the third leg. So, we started off by doing purple and orange. So if I do purple and orange together, is that bigger than the green leg? If I put purple and orange right next to each other, is that bigger than the green one? Yep. So let's name that. What is the side with the purple? AC. And if I add that together with the orange, how did I label my orange? CB, that has to be bigger than the green side. Which one is the green side? AB. But this has to work in all the different combinations. So right now we're just starting with purple and orange, but I need to try it with all the combinations.
What's another way we could add two colors together, two sides together?
So rather than putting orange and purple together, what two could I put together? Orange and green.
Okay, let's try. So orange and green together.
So orange and green together, does that create a longer line than the purple?
No. The orange and green together is bigger than the purple? Yeah.
Yep. So orange and green, I'm going to do my green is AB. With my orange, CB is bigger than the purple. So we did together and orange and green together. Which two have we not put together yet? Purple and green. if I put purple and green together, is that bigger than the orange? Yeah, you can't even see the endpoints of my purple-green, but you can tell compared to the orange, it's bigger because this one goes off the screen, right? So purple and green, I'm going to go with purple first. Purple is AC. With my green, what's the side that's green? AB. And that is all greater than orange. And orange is CB. Alright, now if I try it with one that we said didn't work. We did red, orange, and purple. Why does red, orange, and purple not work? Which one isn't going to be bigger? If I combine red and orange, is that bigger than the purple? Yep. What about, what part doesn't work? Which two would I combine to not work? Orange and purple. If I combine orange and purple, is that bigger than the red? Sorry, you can't really see it. Is that bigger? Nope. So in order to create that triangle, if I clip that on there, sometimes if it doesn't work one side, you have to do the other side. In order to make that triangle, this has to get a smaller length. And so since that red is longer, to make it longer, it's just going to get straighter and straighter, and it won't create that triangle. So if this triangle inequality theorem doesn't work, we're going to get something like this, where it doesn't actually close. So I'm going to show that over here, just to say that this is what happens. So I would have my orange, a really long red, and then my purple wouldn't actually close all the way. It would look like it's about to close, but there would be that space left over. So this is not a triangle. This does not work. Okay, and that would happen anytime where if I put two things together, that third side ends up being longer than that other side. Alright, we have 3 examples, and then we do have a proof to do today. So most likely you'll be coming back after lunch to some notes still, and that's okay. We'll survive. Alright, for our first set, we're going to determine if we can make a triangle with the following side lengths, or with the side lengths. Alright, so for problem number 1, we're going to have 7 feet, 8 feet, and 2 feet. And in order to know if this is going to create a triangle, we don't actually have, we could cut out like a ruler that's 7 feet long, 8 feet long, 2 feet long, or cut out like PVC pipes and see does it make a triangle. That's a lot of work. So instead, what we're going to do is just check with our triangle inequality. When we add 2 sides, it has to be bigger than the third side. So I'm going to just color code these. I'm going to have one that's yellow, my 7 foot. I'm going to do orange for 8 foot. And I will do blue for my last one, 2 feet. Just doing all the colors today. Alright, so when we add 2 together, it has to be bigger than the third side. So which 2 should we start by adding together? Okay, so when I add 7 and 8, that has to be bigger than 2. What other ones can I combine? Okay, so if I combine 8 and 2, what does that have to be bigger than? What's the third side we're missing? 7. And then what's the last combination? 7 and 2 have to be bigger than, what's the third side? 8. Okay, I like to write them all out first and then color code them. Some people color code them as they go. Some people color code them and do the math as they go. What's really important is all these numbers that we're starting with are the 3 sides that we were given. We're not coming up with anything new here. Okay, we're just rearranging them into the 3 different ways that they can be paired together. Alright, so in that first one, what is 7 and 8 together? 15. Is 15 greater than 2? Yeah, and that one we really shouldn't have had to think too hard for, because is 7 greater than 2? Yeah, so even though, so since 7 is greater than 2, if I add something to it, will it still be bigger than 2? Yeah. Okay. 8 and 2 together make 10. Is 10 greater than 7? Yep. We should be putting like stars or smiley faces by these, sorry. It's a good thing. So that works. 10 is greater than 7. We want this one to be bigger. And then 7 plus 2 is 9. Is 9 greater than 8? Yep. So, could we create a triangle using these side lengths? Yes. Now you're probably like, why the heck would I ever do this? Well, the other day my husband found pieces of wood in our garage and he wanted to make a sandbox out of it. We don't have kids, but we have friends with kids who when they come over they're very bored because they have nothing to do because we do not have kids. Okay, so he was creating a sandbox and he was like, I don't even have to cut any of these. And I was like, really? Do you not have to cut any of these? And it was really interesting because, I mean, obviously, if you just have 3 boards, you can try and decide, do they make a triangle, do they not? It takes a lot less time than writing this all out. But I was like, I don't think they make a triangle. It was very interesting. They didn't.
If it's only 3 boards, it's not a sandbox.
Okay, a sand triangle. You're right. It's not a sandbox. My bad. Alright, number 2. We had like a sand... Did any of you guys have like a... We had one of like the farm tires that was a sandbox for us.
Why does it sound like a horror movie? The Triangle of the Sand.
Triangle of the Sand. Alright, next one we have 47 meters, 14 meters, and 26 meters. Alright, so again, we want to check to see if all 3 combinations work. Why not? Thanks, Shmarky. Appreciate it. Alright, what 2 can we combine first? 47 and 14 would have to be 26. What else could we combine? 26 and 14 would have to be bigger than 47. And what's our last one? 47 and 26 have to be bigger than 14. Alright, there's some of these that we don't really even need to do the math for because we know that when I take a bigger number and I add a positive to it, we're going to get a bigger number, right? So 47, that totally made sense. It was mathematical. 47 is already bigger than 26. If I add 14 to 47, will that answer be bigger than 26? Yep. So we don't even need to check it off or do it. Which other one do we know for sure right away we could just check off and say, yep. Yeah, 47 and 26, both those numbers are bigger than 14. So when I combine those numbers, will I get a number bigger than 14? Yep. What's the only one that I really kind of need to check? The middle one. What is 26 plus 14? 40. Is 40 bigger than 47? No. So I'm going to do an X underneath it. What you're going to see in your practice, which is not today, but when we get to our practice here, is you're going to see that greater than sign with a little like slash through it.
Right, we're saying not, doesn't.
Okay? So in this case, our answer would be no. It only has to be a no for one. If it's a no for one, it's a no for the total problem. In order for it to be a yes, it has to be a yes for all three. All right. We should write a note to ourselves.
Yes has to work for all three sides. If one side doesn't work, it's a no for all.
What would you write for no?
If even one side is, or if even one is a no, it's a no.
Yeah. So yes, it works for all three greater thans. No is if it's one or more not greater than. All right, number 3, we are going to be asking ourselves, what are the options for the third side? No, this is number 3.
Did you miss?
What are the options for the third side? Okay, so we have 4 inches, 20 inches, and then we don't know the third side, so the third side we'll use a variable. Does anyone have a variable that's on their mind today that they really want to use? G? I heard G first, sorry. So then we have G inches. Now you're going to pretend to listen since you're not in your seat? Okay. Alright, so we have 4, 20, and G, which means when we add these together, they have to make those 3 inequalities. So what 2 could we combine first?
4 and 20.
Okay, so when I add 4 and 20, that has to be bigger than the third side, G. What else could we add together? 4 and G will have to be bigger than 20, and G and 20 will have to be bigger than 4. So we need a number for G that would make all of these true. Okay? So in this first one, what's 4 plus 20?
24.
24. So 24 is going to have to be the biggest number that G can't actually be 24, but G has to be less than 24. 24 is the biggest number we have. G would have to be smaller than that. Okay? And this one here, to find our boundary for G, we're going to solve. So I have to undo that adding 4. And how do we undo adding 4? Minus 4. If we do it on one side, do it to the other side. So G would have to be greater than 16. And in this last one, remember, G plus 20 is greater than 4. Does it matter what G is here? No, because if G is a positive number, if I add 20 with that number, is that number going to be bigger than 4? Yeah. So this one we don't really need to think about. So what we know is that G has to be between 2 numbers. And as long as it's between the 2 numbers, we'll be able to create a triangle. What 2 numbers does it have to be between? 16 and 24. So I heard 2 people saying 18. Would 18 work for each of those?
Yes.
Yep. What else would work for both? 19, 22.6. Anything that would be between 16 and 24 is going to work. All right, we have one last problem. This one is going to be a proof. we're going to do a flow proof. How many of you did a flow proof in your last geometry class? Okay, anyone who had me last try should say, yep, flow proofs, we did. If you had Miss Lundy or Mr. Varst, or you just transferred back into geometry for one trimester quick, you might not have done a flow proof. And that's okay, we're going to go through a flow proof. I really like it, just kind of putting your ideas out there and connecting them to different parts. I like it better than a 2-column proof, especially when it's like this thing really has nothing to do with this thing, but then they come together to make this new thing. How great. And you guys are like, okay, cool. All right. Exactly. All right, we're going to start with this triangle here. This is G, H, and F. And then from that point F, we're going to create a new triangle on the bottom that just kind of peeps out of that first triangle there. And this is going to be L and K. All right, what we are given is that GK equals KL. And what we're going to try to prove is that JH, not J, we don't have J, sorry. I replaced the J because I stumbled over J so much last period. FH plus GH is greater than FL. So if I say J, someone stop me and say J is not the right letter. So I'm copying notes that have J on it, but I could not talk. It was a rough time. All right, so for our flow proof, we're going to just kind of create all of our ideas and then try and connect them into different parts. So what's one idea that we know right off the bat? GK equals KL. Our statements go in boxes. So we just draw a box around it. I like to write it first, then draw the box. And then our reason actually goes below it. So why did we write that? Where did it come from? It was given to us. I'm going to mark that on my sheet here that GK is congruent to KL. Or equal to, which is congruent, same thing. All right, now if I take a look at this top triangle, I'm looking at triangle GHF. In triangle GHF, eventually I want to look at FH and GH. That's our goal. So if I look at FH and GH, that's two of the sides, FH and GH. That has to be bigger than the third side. What's the third side of that top triangle? GF, yep, or FG. It doesn't matter which one do you guys want to do, GF or FG? GF. And that's based on what we learned today. That's the Triangle Inequality theorem. But we could do the same idea with this bottom triangle. I'm going to color that one a little bit red. We'll go probably a little darker. In that bottom triangle, I want something to be bigger than FL in the end. So if FL is my third side, what two sides would I add together to be bigger than FL? In this red triangle, what two sides would I add together to be bigger than this FL? KL and KF. And again, that's our triangle inequality theorem. So if I combine our given with this new statement here, what new inequality could I write, or how could I switch it around and write something different? Instead of writing KL plus KF is greater than FL, which one of those can I replace with something that we know is the same? Yeah, KL. What does KL equal to? GK. So I'm going to write GK plus KF is greater than FL. What do we call that when we switch something out that's an equal amount? Good, substitution. All right, now let's take a second. Look at GK and KF. What do you notice about GK and KF? GK and KF. If we add those two sides together, what segment is it actually going to be equal to? G all the way to F. G to K plus K to F is really GF. So I'm going to write that over here. Again, another just side comment. GK plus KF really equals GF. Does anyone remember what do we call that when we add two parts together to equal the whole part? Doing a part plus a part to equal the whole thing. Segment addition postulate. Good. We're doing this a little different than we did in our period one.
Sometimes if you feel like we're just writing random stuff down, it might be helpful to go back and look at what we're actually trying to prove. And we kind of noticed this when we were practicing column proofs too, that sometimes you have some extra information in there, and that's okay, just some extra steps, but keep in mind that we're trying to prove that FH plus G is greater than FL. So we want to find that proof with that green triangle.
So if GK plus KF is GF, when we write this next part, instead of doing GK plus KF is greater than FL, what do we know is really bigger than FL? What is GK plus KF? Is really GF. So GF is really bigger than FL. So close. And what do we call that when we switch it out again? Substitution. Now we know FL is smaller than GF, but what is GF smaller than? FH and GH. So remember when we lined people up and I said like I'm shorter than, who did I say in this class, do you remember? Olivia. And Olivia was shorter than Mohammed. And then what did you know about Mohammed and I? I'm still shortest, and who's still the tallest? Muhammad. So in this case, FL is the smallest. And we know FL is smaller than GF, but GF is also smaller than FH and GH. So FL has to be smaller than FH and GH.
Flow through those arrows to show where we used the information from, or where we got that idea, what kind of led us to the next thing.
So this one's kind of a goofy one because it's similar to substitution. We're switching things out, but this one goes like this is bigger than this, and this is bigger than this, so the first one is bigger than the last one. Does anyone remember what we call that when it's like this, and this, and this, and this, and this one, and this one? Transitive. Awesome. All right, great. Everyone's going to take a deep breath.